Gary Atensi with CNTV, and we are in Denver, Colorado today. Today I have the honor of sitting down with Ray Anderson, who is the founder and visionary of Seeker Engineering. Seeker Engineering came along in 1983, basically providing aerospace data storage and processing solutions, pretty much worldwide. Ray, obviously the logical place to start would be in 1983, but I want to back up a little bit and talk a little bit about even before that. What were you doing before you actually launched the company, and how does one launch an aerospace family company from a kitchen table?
Well, actually it starts in about 1950. I graduated from the University of California with a degree in mechanical engineering in June of 1950. And then went to work for Boeing in Seattle. But it turns out June was when the Korean War started. So I was only at Boeing for a few months before it turned out I was going to be drafted. So I joined the Air Force and became a pilot, went to Korea. When I came back from Korea, I requested the Research and Development Command, stayed in for 28 years. And about the last half of it, I was involved in satellites. Most of them are still classified. That gave me a background in the space industry. And when I retired in '78, I went to work for Rockwell, which is now part of Boeing, on the Global Positioning Satellite. I worked for them about 4 years and saw that I was never going to be the president of Rockwell, so I quit. And in that time, my eldest son, Scott, had graduated from college with an electrical engineering degree, and he also was working for Rockwell and didn't like what he was doing, so he quit. So we're both sitting at home, what do we do now? And about that time, the government came out with a program called Small Business Innovation Research. And they had a catalog about an inch thick that you could bid on items that were there. The law that set it up required the executive department, the DOD and others, to provide items which they wanted and small business could bid on. It was a three-phase program. Phase one was $50,000, and phase two, $500,000, and phase three on beyond. And I was thumbing through it. I saw where the Air Force wanted a solid-state recorder. And from my experience in the Air Force, I knew that solid-state recorders had a future. So I said to Scott, who was home at the time also, why don't we put a bid on this? So on our dining room table, Scott and I researched the subject and did indeed put a bid into what was then the Defense Meteorological Satellite Program, the Air Force Weather Satellite, DMSP as it's better known, and we won. So, just the two of us, we were proposed using what was then bubble memory. They were the most dense solid-state memory that was available at the time. So we, in the phase one program, defined what we were going to do and won the phase two program. And during that program, we designed all of the circuit boards that would be needed for such a recorder. Then they ran out of money. So we're sitting there without any contract at that time. We had moved into a small garage-style office. We did some consulting work, anything we could to keep the office open. And then there was a classified program, heard of us, and they needed a small solid-state recorder. So they came to us, and they were going to give us a sole source contract to build them a recorder. But then their contracts people objected and said it had to be competitive. And there was only one other company, Fairchild, that had done anything with solid state. And they had taken the conventional approach that for solid state devices to work in space, they had to be what's called static rams and radiation hardened. That made them very expensive. Sure. And heavy too, because they weren't very dense, the devices. Right. Well, when we found out it was going to be competitive, Scott came up with an approach that used what's called dynamic rams. They're more dense than a static ram, but everyone thought that their use in space wouldn't work because of the radiation environment. Mm-hmm. So Scott came up with a scheme that used error detection and correction, which was used at the time in telephones, for example. And with that, we could overcome the errors introduced in the dynamic rams by the radiation. That brought, Ball Aerospace, local here in Denver, Boulder really. They needed a small recorder in their radar set program that they didn't have in their budget. So they were willing to go with a small company. We were probably about 6 people at the time, and built a solid state recorder for them, which we did, and delivered it. And that was followed by one from Orbital Sciences. They also wanted a small recorder without much money. We didn't cost much. We didn't take any salaries out of the program for about 10 years. Martin, across the valley, it was Martin then, not Lockheed Martin. They needed what was then a very large capacity recorder, and they went out to industry for proposals. And we, along with 11 other industry companies, bid on it. But we were the only ones that ever built a solid state recorder. Right. So we won the contract. And part of that, our proposal was that we would move into the Denver area so that they could keep their eyes on us. Right. And that's what brought us to Denver, to Centennial really here. Mm-hmm. And that kind of shook the industry up, that this small outfit they had never heard of won such a contract. Sure. So that really brought other contracts to us. And through the years, we have come to become the leading manufacturer of solid state recorders. We probably have built more solid state recorders and have them operating in space than the whole rest of the world put together.
And you were able to do these, they were more reliable? Were they less energy? How do they work?
All of that. They're much smaller, mm-hmm. lighter, and it can use much less current energy.
Tell me a little bit about the facility here.
We built it just for our specific flow, which brings in the parts at one end of it, and we inspect the parts. Then they go into our manufacturing area where they are soldered onto the circuit boards that we had designed. And then in the space industry, you have to test every box extensively. So we have a test area set up downstairs, and we then put them in a thermal vacuum chamber so that we can test them into the space environment.
A family-based aerospace company, I think, has to be kind of a rarity.
Oh, very rare. We've never run into another. And that really was a difficult situation to overcome, that the industry would go with this small family business. So we have progressed from there into all of the other electronic items that spacecraft need. And particular, we have gone into processors. And last summer, we won a $134 million contract from the French to build the onboard processors for the Iridium constellation. The Iridium constellation is a constellation of 66 satellites that is used for telephone service throughout the world.
Well, it's been a great story, Ray. I appreciate you sitting down with us and letting our viewers know a little bit behind the scenes, the human side of the technology here in the building. And we appreciate that. And as you can see, folks, Ray here started after retirement. He actually sat down with his son there, and they were just wondering what they wanted to do. And lo and behold, the son came up and figured out dynamic RAM, and Ray had a great background in history and launched something that nobody else had really done at that time, and which brought him here to Denver, Colorado. And Ray will continue to be at the helm of the company along with his sons and continuing a great family tradition here at Seeker Engineering. This is Gary Atencio with CNTV, and if you don't know, now you know.